Okay. Good evening, everyone. Welcome to Fuzzy Sets Logics and Systems and Application, week 12. So, we are in our last week today, and this is going to be our last class. And I'm your teaching assistant. My name is Saladi Pravadika. I'm a PhD student and a Prime Minister Research Fellow at the Indian Institute of Science. So, before we get started, this session is being recorded, and please be respectful during the session, and please put all your questions in the chat box. So, one thing that I have to tell you before I begin is I did a really big mistake. So, the mistake is that I have to fill a form for an additional problem solving session. And I was just thinking that I did not get the mail until a friend of mine told that she has already filled. And that is when I started checking my inbox. And turns out the mail directly went into spam. So, and the deadline has passed, and I could not fill the form for the extra session. So, that was one mistake that had happened, and there won't be any extra session. I'm really, really sorry. I'm regretting it so much. So, yeah, so there is no other way where I can have the extra session. I thought I'll have it on this next Tuesday, but I was just thinking I didn't get the email. But and I'm so sorry. But okay, so what's done is done, so we can't do anything. So yeah, so this is going to be our last class officially. Okay, so with that, let's get started with today's class. And also, I have a bit of throat infection, so I'll be taking breaks in between. I don't want my voice to just go away. Anyways, so in the last week's class, we have discussed about Mamdani fuzzy model. And in this week, we will be discussing one of the models that we will be discussing today is Larsen fuzzy model. So Larsen fuzzy model is also similar to that of Mamdani, where you have a fuzzy rule base and you have around 10 rules. Okay, so you have total of 10 rules, and your AI and BI. So these are your input membership functions, and they have their own respective universe of discourse X and Y. So AI has a universe of discourse X, and BI has the universe of discourse Y. And so these are the inputs, and for the output, you get a membership function CI, and that has a universe of discourse Z. Yeah. Okay. So this I here is basically nothing but it starts from 1 until goes on till n, 1, 2, 3, and so on till n. Okay, so how many number of rules you have, those many number of inputs you'll need from A, and those many number of inputs from B, and finally you'll get also those many number of outputs, right? So here we have something. So representation wise, so AI is given in this way: integral new AI of x for a given value of x, and same for bi and ci as well. So in case of x, you have y and z respectively. And we have okay. So the antecedent and the consequence that we write is that if x is ai and or, so as you all remember, and or are the connectives. It can, so I can either say if x is ai and y is bi, then z is ci, or I can also give it as x is ai or y is bi, then z is ci, right? So this x is ai and y is bi, so this is our antecedent, and z is ci is our consequence, right? So for this, we have something called as firing strength for every rule. So if I'm at the ith rule, I have a different firing strength, and we can also call it as weights. And this is represented as WI. So this WI can be defined in two ways using two different compositions. One is for maximum composition, and another one is for max product composition. So in maximum composition, when we are talking about the firing strength or the weight, we take the intersection between membership function of A and membership function from B, right? And you take the minimum value, that is the intersection between both of them. And for max product composition, instead of taking minimum or the intersection, you take the product, right? So this is your firing strength of ith rule, or it's also called as weight. So once you get the weight, then you go for the membership function. So for you to write the membership function, you should have your membership value, right? So this membership value can be obtained using, what is this here? You have this weight wi for the ith rule, and then you have new ci. So then you take the product of both of them, and then you take the maximum of all of these. So from all the rules that you have from I to N, among all of that, you pick the maximum value, and then you'll have your final output will be C dash is equal to you, and then you give the integral nu C dash of Z. Okay, so this C dash is a fuzzy output, and it can be further defuzzified, okay, using the defuzzifier. And we have looked at some of the methods of defuzzifying in last to last class, I guess, right? So I hope you all remember that. Yeah, and similar to the previous Mamdani fuzzy model, we do have three different cases where you have a single rule with single antecedent, and then you have a single rule with multiple antecedent, and you have multiple rules with multiple antecedents. So bringing up each case and trying to like get the values and out of that is like with pen and paper is kind of time consuming and all of that. So I didn't put all of those case studies here, but you are always, it's always better if you go back to the original class videos and go through each cases along with the values and everything. So if I do it on just with pen and paper, it will be like vague values I'll be taking, right? So I have skipped the examples for each of the cases and all of that. So as a whole detail, I'm just giving you here. Okay, so that is with Larson fuzzy model. Okay. Mm. Okay. Uh, Amber, is it still not visible? Okay. So it was visible from the beginning, right? You didn't miss anything. Yeah. Okay. Thank you. Okay. So that's with our Larson fuzzy model. And the next one we have is Tsukamoto fuzzy model. Okay. Just give me 1 second. Um, okay. So next we have Tsukamoto fuzzy model. So so basically Tsukamoto fuzzy model, it is a rule-based fuzzy inference system just like the other two. But the main catch is that so the consequent of each fuzzy if then rule is represented by a fuzzy set, which is monotonic membership function. So it is either increasing or decreasing. Okay, so it's not both, it's either one of them. It's either increasing or a decreasing membership function. Okay, so that is something that you all need to remember. So I'll just start here. Okay, and the main thing that you have to remember here is that the output is going to be a crisp value. For Mamdani fuzzy model and Larson fuzzy model, we had it to be a fuzzy output. And then we had the need for a defuzzifier. But whereas in Tsukamoto fuzzy model, it does not, it gives you directly a crisp value. So which means that you don't even need a defuzzifier anymore, right? And this crisp value is calculated by taking the weighted average of rules outputs. So each, if I'm having the n number of rules, you'll have n number of outputs, and then you're going to take the weighted average of all of them, right? Huh. So the main advantage with this Tsukamoto fuzzy model is that there is no need for defuzzifier, as we have discussed, and hence it avoids all of this time-consuming process. So defuzzification usually takes a lot of time. So since this doesn't have it, so it's time-wise it is an advantage, and also the computation-wise. Okay, and it does not use any compositional rules. So before we had like max min composition or max product compositions and all of that, but in this Tsukamoto fuzzy model, you will not have all of that. So this is also similar. You have two input membership functions, AI and BI, and it has like n number of rules, and the output is going. So here the output is not, sorry, it's not going to be a fuzzy value. It's just going to be a single crisp value, right? Okay. Huh. So for this, the firing strength or the weight, so the firing strength of the ith rule, and it is defined by taking the intersection between new A and new B. That is the membership value from fuzzy set A and the membership value from fuzzy set B. For a given value of X and Y, you take the intersection. Right. So once you get the firing strength or the weights, then you go for the overall output. So this overall output is taken as a weighted average, right? Not just any normal average. So when I say weighted average, it means that at the denominator, you have the summation of all the weights. And in the numerator, you take the product of the membership value of Z. Sorry, you take the Z, and then you multiply it with the weights W, and then you sum it all up, right? And this Zi is nothing but output of each rule. Okay. Okay. So when you take the summation, the final thing that you are going to be left with is this Z star. So here you'll have a Z star, right? Any questions so far? Okay. And similarly, this also has three cases: single rule with single antecedent, single rule with multiple antecedents, and multiple rules with multiple antecedents. Okay. So again, here I did not give you all uh, the case functions, case studies, and all of that. Okay, for that, I'd suggest you to directly look at the notes. Sorry, the lectures. Okay. And the final model that we have is this TSK fuzzy model. So T stands for Takagi, and S stands for Sugeno, and K stands for Kang. So this TSK fuzzy model was developed by these three people in 1985. And here your consequence is going to change. So far we were having the consequence to be a membership. Sorry, it was a fuzzy value output, right? So it was a crisp one. But here it's more like the Z is equal to some function in the terms of X and Y. Okay. Hmm. And yeah, this is usually the form for this TSK fuzzy model. So before we were having if X is AI and or Y is BI, then Z is C, and all of that we were giving. But here it is like if X is A and or Y is B, then Z is equal to f of X comma Y, where so this Z is going to be again a crisp function, but not a crisp value. Okay, so we'll write it somewhere. So this f of x comma y can be represented as p naught. So this p naught is a constant. That's the only constant that is there in the entire equation. And then we have p1x plus p2x square plus so on till pn xn plus q1y plus q2y2 plus so on till qn xn. So this n is again the total number of rules that you have. Okay. And the main advantage of this TSK fuzzy model is that it is less it takes less computation time. So compared to any other fuzzy models. So in this, the input type is a crisp type and also the output type is also a crisp type. Okay. Values. Okay. So I'd suggest you to like kind of take all the four fuzzy sets, fuzzy models that we have discussed so far, Mamdani, Larson, TSK, and sorry, I forgot the last one's name, Tsukamoto. Okay, so take all of them, draw a table, differentiate among all these four, okay, in terms of the way they take the inputs, the way they give the outputs, and if the defuzzification problem, defuzzification is included or not, and all the things like that. Okay, so so that you will just have all of these in mind. Okay. Ah. And for this also, the output is obtained by using a weighted average, just like the Tsukamoto fuzzy model. And hence there is no defuzzification since we are getting a crisp value as an output. Okay. So in this equation, let's just look at the f of x comma y. In this equation, if I put the value x equal to 0 and y equal to 0, then the function is going to be equal to p naught plus 0 plus 0 plus 0. Everything is 0. So the final value is going to be p naught. So here the p naught is actually a constant. All of these p naught, p1, p2, q1, q2, q3, all of these values are some constants. Okay. Except for p naught, we are attaching x or y to that. But when we put x equal to 0 and y equal to 0, and when we have it equal to p naught, we call that as a 0-degree polynomial, TSK. Okay. So in general, we call it as a 0-degree polynomial, but in this case, we call it 0-degree TSK. All right. In case, uh, if we have p naught plus p1x plus q1y, so there are no other variables which has a degree greater than 1. Okay, greater than so any degree greater than 1 is not there in the equation, then we call it as a first order polynomial or a first order TSK, right? So it's going to be p naught plus p1x plus q1y. So if we have this, then it is a first order TSK. And again, we have our AI, BI as inputs. Oh, sorry, shouldn't take this as inputs. Okay. So we have the inputs AI and BI, right? And then the the firing strength or the weights are nothing but WI is equal to, you take the intersection between both of the membership values and then you take the overall output as Z star, similar to what was there in the previous one. The only catch here is that this Zi is a polynomial. Okay. Polynomial input variables x and y. So this Zi is similar to that of the f of x comma y that we were writing before. Right? So again, this zero order I've written here. So except for p naught, everything else is 0. And so the final output is a p naught, which is a constant. That is the zero order TSK fuzzy model. And then we have 3 cases: single rule with single antecedent, single rule with multiple antecedents, and multiple rules with multiple antecedents. Right? And And then we have our first order, right? In the first order, we have only the variables that has a degree 1 or less than 1, which is basically 0 and which is a constant. So P naught plus P1x plus Q1y is called as the first order TSK. Right? And these are the cases that we have. Right? Any questions so far? Any questions? Okay, no questions. Fine. Okay, thank you, Amber. So, let's just give a brief recap of everything. Okay, so we have seen the Larsen fuzzy model. It takes two fuzzy values as input and gives a fuzzy value as an output, right? And then for the procedure for this is we take the weights. In this, we have two different weights based on the composition that we are following. If we are following the max-min composition, you take the intersection. But in case if you're following the max product composition, then you take the product, right? And then you take the union, that is a maximum value of all of these things, right? And then we had looked at the Tsukamoto fuzzy model, where each okay, so where the inputs are fuzzy values, but the output is a crisp value. So which means that defuzzification process is not required, and hence the the model is going to take less time. So it's going to consume less time, right? And this one does not follow any composition, the max min or the max product composition. So for the weights, you directly take the intersection, right? So for the firing strength or the weights, you just directly take the intersection. And for the overall output, you take the weighted average. Weighted average is nothing but you divide the summation of the product of weights with Zi by the summation of all the weights, right? So Zi here is nothing but the output of each rule. And then we have the TSK fuzzy model, where uh, the rule itself is sorry. So the representation itself is like if x is a and y is b, then instead of having z is c, we have a polynomial where z is equal to f of x comma y, and f of x comma y is equal to p naught plus p1x plus p1x square, so on, and then plus q1y plus q2y square and all of that. So this p naught, p1, q1, q2, all of these are constants. So if I put the values x equal to 0 and y equal to 0, then we get f of x comma y is equal to p naught, which is equal to a constant. Then we call it as a 0-degree TSK fuzzy model. If we have with x comma with the degrees of the equation to be equal to 1, so that is no x square, no x cube, no y square, no y cube, and everything above that, then it is called as a first order TSK. Right? In this, the computation time is going to be less, just like the Tsukamoto fuzzy model. And this also follows a weighted average. But the only difference here is that the input types are also crisp values, and the output is also a crisp function. Okay, and this also does not require a defuzzification process. Right? And for in-depth analysis, you can have a look at the video lectures. Okay, so so that is the entire summary of what we have done in the class so far. Okay, and now let us look at some of the questions from previous years. So this is the first question. So I'll just give you 2 minutes for you to just go through the questions first. Okay. Okay, I'll just give you 2 minutes. If needed, you can write it down. Write it down and just let me know when I can start back. Okay, Amber, we'll look at the solution. So I'm just giving some time so that people can note down the question. Please note it down because from the same question will be used again and again for the next ones. So okay. So I'm starting. So we have two rules here. The first rule is if x is high and y is low, sorry, and then we take the z is equal to x plus 2. So for at the consequence side, we have a polynomial, and hence this is a TSK fuzzy model. So here it is mentioned that it is a TSK fuzzy model, but sometimes in the question it won't be mentioned also. Okay, so you just have to keep an eye on that. So in rule 2, if x is low and y is high, then z is equal to y plus 1. Okay, okay. Now we have our rule set. And then we also are given our input membership functions, x low, x high, y low, y high. Okay, and I have written the triangle values here. Sorry, triangle function here. Okay, so let's find out the values. Hmm. So first, let's do it for x of low, right? So for this, we have the triangle x for 1, 3, and 5, and we have our x value to be 1, right? So this is for x equal to 1. Okay, so it's max of minimum of 1 minus what is a 1 divided by b value is 3, 3 minus a is 1, so, comma c value is 5, 5 minus x is 1, and 5 minus 3, comma 0, which is equal to max of minimum of, this is 0, this is 4 divided by 2, which is equal to 2, comma 0, which is equal to max of 0 comma 0, which is equal to 0, right? So we got x of low equal to 0. Hmm. So for a rule to be true, we should have these values as anything but 0, any value except 0. So now I'm saying x of low at x equal to 1 is 0, which means that rule 2 is not going to work. X low is not going to work, right? So I can make a blind guess here that I don't have to prove that y is high, is having 0 or not. So I'm just going to skip that part for this particular question only. Okay. So okay, rule 2 is out of the picture now. Let's look at rule 1. So we have x is high, y is low. So let us look at x is high. at x equal to 1. So same goes again. So max of minimum of x is high. It's 2, 4, and 6. So x is 1. This is 2 divided by b is 4 minus 2, comma, c is 6, x is 1, c is 6, and b is 4. So, so which is equal to max of minimum of, this is minus 1 divided by 2, which is minus 0.5, comma, this is 5 divided by 2, which is 2.5, right? So, comma 0. So, which is equal to max of minus 0.5, comma 0, and maximum of these two values is equal to 0. So, we have x high is also x high at x equal to 1 is also equal to 0. And hence, rule 2 is also out of the picture for us. Okay. So, rule 1 is also ruled out, rule 2 is also ruled out, and hence none of the above is the right answer. So none of the set of rules applies to the given fuzzy model, and hence we have none of the above. Any questions in this? Okay, I hope there are no questions. Now, for the same question, let's look at it in a different way. Here we have x equal to 2 and y equal to 7, right? So the values have changed from what was there earlier. So I want you guys to do this. I'll wait till 6:40. Okay. I have given 8 minutes. That is more than enough. And I want you all to find both x high, x low, y high, y low. I want you to find all of the four values, and I want you guys to give me the values that you are getting for all of these, and then tell me what are the rules that are applicable. Okay, I just don't want just the pick the right answer. Okay. Okay, Amber says rule 2 will be satisfied because the membership values are non-zero for this rule. I want the x of low, x of high, y of low, y of high values as well. What are the values that you have got for the given triangle function? Very good, Janani. X low is 0.5. And the other ones? Yes, Amber. X low is 0.5, X high is 0, Y low 0, Y high is 0.5. Great, awesome. But I'll just wait for 4 more minutes till 6:40 so that if anyone else want to finish, and then we'll start. Okay. Okay, any more answers? Janani? Okay. So we'll write. So X low is 0.5, Y high is 0.5, and these are zeros. Okay, so up to obtain them, you just have to put these values x equal to 2 and y equal to 7, and a, b, c values which are already defined in the previous one. Here, you just have to put it in this equation, and then you will get your membership values, right? At for given x values and at given y values. Okay, and so these are the membership values that we have got for x equal to 2 and y equal to 7 at low and high. So the non-zero values are x low and y high. Y high. Right. The rules that we were given are rule 1, if x is high and y is low, then, okay, let us just say some consequence. Our rule 2 is if x is low and y is high, then some consequence, right? Now we have two non-zeros. One is x is low and y is high, right? So rule 2 applies for this given value of x equal to 2 and y equal to 7. Okay. So just little bit of change. I just want to ask a different question. Okay. These are a different set of one different set of rule that I'm giving. Let us call it as rule 3. Okay. If x is low or y is low, then some consequence. Does rule 3 apply? Any answers for this? So I'm giving another rule 3 where x is low and x is low or y is low. Then some consequence. So my question is, will this new rule 3, which is there for the same values, which we got earlier, applies or not applies? If it is yes, then why does it apply? And if it is no, why it doesn't apply? Okay, Amber and Janani says yes. I want the reasons from both of you. So Amber says because or means taking maximum membership value, which will be non-zero, that is 0.5. You're absolutely right, Amber. Okay, now just like an additional thing. Okay, rule 4. Okay, so if x is low and y is low, then some consequence. Rule 4 applies. Does not apply. Great, Amber and Janet. So now the thing is, if we are having or, either one of them should have a non-zero value. If we have and, both of them should have non-zero values for that rules to be applied. Okay. So so with these two questions, keep these things in mind. Okay. Now let us quickly go to the next question. So for the applicable rules obtained using CRISP inputs in Q1, what will be the firing strength using max min composition for TSK model defined in question 1? So we have a question 1 here. Okay, so now you require Y low and Y high as well. Please find Y low and Y high. X low and X high are 0. For this question, please find these and let me know what's the answer. I'll just write the values here. Okay. Amber says y low is equal to 0.5 and y high is equal to 0. Okay. So what do you say is the firing strength? So this one is question 1. If there are two rules, you do it for two rules. Whichever rules are applicable, you do for those rules. You want to look at the question 1? Okay. So you feel the firing strength will be 0 for Q1. So here's a twist. So you only have to find the firing strength for the rules which are applicable to the given inputs. But in question 1, we told that none of the two rules will apply. Rule 1 doesn't apply, rule 2 also does not apply. So there is no point in even finding the firing strength. Okay. So for this, none of the none of the above is the answer. So no rules apply. Question 1. So always keep this in mind before you find the firing strength. Make sure that the rules do apply. Okay. If the rules are not applying, you don't even have to bother finding the membership of firing values. Okay. Now, okay, for question 1, let it be. Now, for the applicable rules obtained using the crisp input values in Q2. Okay. This is Q2 before we did it for Q1. Okay. What will be the firing strength using max min composition for the TSK model obtained in Q1? If one will bring this part here, I don't think I can take this one out. Not working. Okay. Just remember the fourth question. So you need to find the firing strength and the composition is maximum composition. For the values in Q2, that is x equal to 2 and y equal to 7. And for these two rules, rule 1, rule 2, what is the firing strength? Okay. Uh, we'll just give 2, 3 more minutes. Okay. So Janani also can do. Okay, so I'll just go ahead. Okay, so for Q2, we said that rule 2 is applicable, right? And rule 1 was not applicable, right? So in that case, when x is low, that is it's 0.5, and y is low, sorry, no, y is high, which is also 0.5. Let's write it here. X of low 0.5, y of high is 0.5. So this is from rule 2, since only rule 2 is applicable. So here we have max min composition, which means that we'll take the minimum value. So your W is going to be 0.5 intersection 0.5, which is equal to 0.5. So 0. So option A is the right answer, as Amber also said. Okay, very good, Amber. Okay, next question. So for the same thing, if we use max product composition, what will be the firing strength? So for rule 2, we have X low 0.5, Y high 0.5. When we take the max product composition, we take the product of the both the membership values that we have, right? So W is going to be 0.5 product 0.5. So which is equal to 0.25, which is C. Very good, Amber. Okay. And then we have TSK model defined in Q1. Which of the following set of rules will be applicable for crisp inputs x equal to 5 and y equal to 3? Okay, go ahead and do this. I'll give you time till 7. Okay. Number, I want all the values. X low, X high, Y low, Y high, and all of that for x equal to 5 and y equal to 3. I want all the values. Okay, I'll wait till 7. So others can also do it. Okay. Any more answers? Okay, so Amber says X low and Y high are 0, and X high and Y low are 0.5. Okay, so yeah. Okay, let's check. Generally, what are the X low, Y high, X high, and Y low values that you have got? You can just write it like in numbers: X low, X high, Y low, Y high. Just numbers you can give. Don't have to type the whole thing. Why are the messages delayed for me? Okay. 0, X low 0. Oh, okay. Nice. Okay. So we have X low is 0, Y high is 0, X high is 0.5, and Y high is 0.5. Right? Okay. Hmm. Okay. Hmm. So what are the rules that we have? Rule 1 is X is high, Y is low. X high and Y is low. The second one is X low, Y high. Yeah. So this is rule 1, this is rule 2. So according to us, X high is this is 0.5, and then we have X Y low is 0.5. So these two are non-zero, right? And this one is 0 and this one is 0. So when we have a non-zero value, then that rule does not apply, right? So rule 2 does not apply. Rule 1, we have both of them non-zeros and the connector is AND. So we need both of them to be non-zero, and hence this rule 1 applies, right? So the option is B, right? So which is rule 1. Yes. Yes, Amber, yes, generally. Both of you are right. Okay. Okay. Let's go to the next question. So, for the applicable rule obtained using given crisp inputs in question 6, the question which we had just done, what will be the firing strength using max min composition? Okay, any more answers? Okay. So, we have for the applicable rule. So, the rule that applies for question 6 is only one, which is X high and Y low, right? And we have X high equals to 0.5 and Y low is equal to 0.5, right? And the composition that we are using is max min. Max min means for the weights, we are going to take the minimum. So if we are having max product, then we are going to take the product. So since we are at max min composition, we are going to take 0.5 intersection 0.5, which is nothing but minimum of 0.5 comma 0.5. That is equal to 0.5. And 0.5 is your answer. Okay. Now let's look at the eighth one. So for the same question, if you are using a max product composition, what will be the firing strength? Okay. Again, fairly simple. X of high is equal to 0.5. Y of low is equal to 0.5. So the weight is equal to 0.5 product 0.5, which is equal to 0.25. Yes, Janani and Amber, you both are right. Okay. Now, let's look at the ninth question. For the applicable rule obtained using given crisp inputs in Q6, what will be the aggregated weight output using max min composition? So the aggregated weight is something like that's a Z star. Any answers for this? Value of, okay, x equal to 5, y equal to 3. I'll write it here. Okay, Amber. Okay, let's look at it in this way. So here Zi is nothing but the output of all the uh, rules that we have. And we all know that in question 6, it is solving only for one rule, right? So I can rewrite this as, since I have n equal to 1, so which is also equal to I, W product Z divided by W. I can just cancel out these W's, right? So it will just leave me with Z. Okay. So the Z star is going to be Z. So let's look at the equation, rule once. So rule 1 is applicable, right? So if Z is high, Y is low, then Z is equal to X plus 2, right? That is the consequence that we got. What is this? So Z is equal to X plus 2, which is equal to 5 is your value of X plus 2, which is equal to 7. So Z star is equal to 7. Sorry, Z, which is equal to 7. And you get your value as 7. In case, okay, just in case, if rule 1 and rule 2, both of them are applicable, then what you have to do is you have to take the weights as per this, whatever composition is given. So here max min is given. So you go and take the max min for rule 1 and max min for rule 2, and you get the weights W1, W2, and whatever outputs the Z value, Z star values that you're going to get. Sorry, ZI values that you're going to get for each output, you take that. So similar to how I got here. No. So you take those values and then you divide using the whole weights, all summation of all the weights. and then you will find your Z star. If more than one rule is applicable. If one rule is applicable, this is how you can just cancel out the weights and then give the value of Z directly, right? Okay. So the last question. For the applicable rule obtained using crisp input values in Q2, what will be the aggregated weight output using max min composition? Okay, let's look at Q2. What are the values we have? X equal to 2 and Y equal to 7. X, so X equal to 2, Y equal to 7. Can you find the aggregated weights for this? Okay. Janani, any answer from you? Eight. Okay. Very good. Let's see. Very good, Amber and Janani, both of you. So let's again do it the same way. We have Z star equal to summation of Wi multiplied with Zi divided by summation of Wi, where I is equal to I goes from 1 to n. So here our n value is equal to 1 and only rule 2 is applicable, right? Okay, so our Z star is nothing but W into Z divided by Z. So sorry, W. W cancels out and which is equal to Z. So for rule 2, the Z value is equal to Y plus 1 and we have Y is equal to 7 and hence it is 7 plus 1 which is equal to 8, right? And hence our value is 8. Okay. So for example, uh, let us say hypothetical question I'll give. I don't know if it's just a hypothetical question. Just wanted you guys to like do this and know how to do it. Okay. Hmm. Let us just take the same rules again. Let us say for x equal to 5 and y equal to maybe let's say 8. Okay. Let us say both assume both rules are applicable using max min composition. What is the aggregated weight? Okay, it's just a hypothetical question. I don't even know if x equal to 5 and y equal to 8 satisfies these rules or not. I'm just giving. out of the blue. Okay. You guys want me to do it? Uh, okay. We'll see which values will satisfy it. We have to take something. No, I'm just saying, just assume that this rule applies. Okay, just assume. Assume that it applies. Okay. Um, and for the weights, okay, let us take some assumption of the weights also. Okay, assume the weights. Uh, okay, this is just a hypothetical question so that you'll understand if more than one rule is applicable, how to calculate it. Any answers? Okay, let's do it. So this is all based on our assumptions that rule 1 and rule 2 are applicable and for some random values of x and y. Okay, and some weights also we have taken out of the blue. Okay, so let us say z1 is equal to x plus 2, which is equal to 5 plus 2, that is equal to 7. So z1 is from rule 1. Okay, and then so z2 is equal to y plus 1, which is equal to what is it? 8 plus 1, which is equal to 9. Right? This is root 2. Now we have I gave you some random w1 w2 values also. Just let us just assume those weights are right. So z star is equal to summation I is equal to 1 to n uh, z sorry wi multiplied with zi divided by zi for I. So ZW for I equal to 1 to n, right? So which is equal to W1 Z1 plus W2 Z2 divided by W1 plus W2, which is equal to 0.3 into 7 plus 0.2 into 9 divided by 0.3 plus 0.2. Okay, so you can calculate this. So it's 2.1 plus 1.8 divided by 0.5. So it's 40. No, sorry. It's 39 divided by 5. So it should be what? 7.47 and no, 7.78 or 8, you can say. Anything is right. Yes, Amber, you are right. Okay. So this is how you do it. Okay. So I'll add another question to this. Okay, since we have some more time. Okay, let us just assume it as 11th question. Again, we are looking at a TSK fuzzy model. Okay. Rule 1, if x is low and y is high, then z is equal to 0.05x minus 0.03y plus 0.5. Rule 2, if x is low and y is low, then z equals y plus 3. Rule 3, if x is high and y is high, then z equals x plus 2. Then rule 4, if x is high and y is low, no, sorry, y is high. Oh, 1 second. I made a mistake somewhere. Low, low, high, 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 low. This should be low. Then z equals 0.05x plus 0.02y. Okay. And the input membership functions. Low of x is equal to triangle x137. U of high is x triangle x of 248. U of low just 1 second. My pencil got shut down for some reason. Technology and the problems. U of low for y triangle y 0 to 4 mu of low of y triangle y of 3, 5, and 7. Okay. So for the first question, for x equal to 5 and y equal to 5, which rules are applicable? So before you answer that, I also want these values. For x equal to 5, mu of high of x for x equal to 5. I want these values first. Where should we follow max min composition model? So, Janani, usually it will be mentioned in the question to follow which composition. So it's either max min or max product. In the question itself, it will always be given. Okay. X low is 0.5. Okay, Amber. X high is 0.75. Okay. Y low is 0. Okay. X low is 0. Okay. So let's write it down while you save. Okay. So even I haven't cross-checked. So I'm just going with whatever Amber is answering. Okay. Janani, you also please do. And in case if you get a different values, just let me know. So if you're getting a different value, then I'll also do it. Okay. So this is 0.5. X high is 0.75. Okay. Y low is 0 and Y high is 1. Thank you so much, Amber. Uh, okay. So let us see. Rule 1. X is low. So we have a non-negative, a non-zero value. Okay. And Y is high. So Y is high, we have it as 1. It's a non-negative value. So rule 1 is applicable. Okay. Now let's look at rule 2. X is low, which is a non-zero value. So yes. And Y is low. And Y is low is a zero value. So rule 2 is not applicable. Let's look at rule 3. If X is high, so X is high, which is 0.75, non-zero value, and Y is low. Y is low is a zero value, so hence rule 3 is not applicable. Then rule 4, X is high, so which is 0.75, which is true, and Y is high, which is equal to 1, so which is true. So rule 4 is also applicable. So rule 1 and rule 4 are applicable for this case. Okay. Now, the second part of the question is for in whatever thing we have done earlier, um, find the firing strengths W1 and W2 using max min composition. Please find the firing strength for both of these rules. Okay, great. Okay, so let's do. So for W1, let us assume it is coming from rule 1. Okay, so for rule 1, we are taking X is low and Y is high. For X low, the value is 0.5. So for Y high, it is 0.75. Since we are using max-min composition, we are going to take the minimum of 0.5 and 0.75, which is equal to 0.5. So W1 is 0.5. All right. Now, for W2 let's assume it's from rule 4. Yes, Janani. Rule 4. What is rule 4? It's X is high. X is high. And Y is what? High. Right? So this value is 0.75. This value is 1. So W2 is equal to minimum of 0.75 comma 1, which is equal to 0.75. Amber and Janani, both of you are right. Okay. So for the same thing, W1 and W2 using max product composition. What is W1? What is W2? We also open calculator. Okay. So when we say max product composition, we take the product of both the membership values that we have. So for W1, we have 0.5 into 0.75 into 0.75, which is equal to 0.375, right? And for W2, we have 0.75 into 1, which is equal to 0.75. Amber, you're right. Generally, just look at your decimal values. Yes, you're right now. Very good. Okay. Okay. So for the same fuzzy model, okay. So what will be the Z1 and Z2 values? Z1 and Z2 values. I can make it smaller so you can see everything at once. Okay. Okay, Amber, we'll just wait for another couple of minutes so Janni also can do. Okay. Please keep doing. I'll just take a 5 minutes break. I need to fill my water and come. So, okay. Just give me 5 minutes. Okay. Thanks a lot for waiting, guys. Right. So let's look at how to do this. So for Z1, which means it is following rule 1. So from rule 1, let us take this f of x or this function f of x comma y, right, which is equal to 0.05 into what is the value of x? Where is this? X equal to 5, y equal to 5. Right, 0.05 into 5 minus 0.03 into 5 plus 0.5. Okay, let me just calculate it. 0.05 into 5. This is 0.25. Okay, 0.03 into 5, 0.15 plus 0.5. This is equal to 0.6. So for that, right. And then for Z2, Z2 is rule 4, which is this one, which is equal to 0.05 into 5 plus 0.02 into 5. So this is equal to 0.25. This is equal to 0.1. That is equal to 0.35. So both of you are right. So once that is done, now find the aggregated weights, weighted average. So it is Z star equals I equal to 1 to N Zi into Wi divided by I equal to 1 to N summation Wi. Okay. So since Amber and Janani both have finished that, so let us see. Sorry. This is equal to 0. This is Z1 into W1 plus Z2 into W2 by Z1 plus the W1 plus W2. So this is equal to 0.6 into what is W1? 0.375 plus 0.35 into 0.75 divided by 0.375 plus 0.75, right? So let's calculate 0.6 into 0.375. This is equal to 0.225 plus 0.35 into 0.75, which is equal to 0.2625 divided by 0.375 plus 0.75 is equal to 1.125. In the numerator, it's 0.225 plus 0.2625, 0.4875 divided by 1.125 divided by 1.125 is equal to 0.433 bar. Right? So, Janani and Amber, both of you are right. It's 0.433 bar. Right? So, this is how we find the aggregated weights, weighted average. Okay. So, yes. With this, I am done with all the questions that I have. Any questions from today's lecture? From all the problems that we have solved today? Hmm. Very good. Thank you, Amber. And so with this, I am done with this week's course content. And once again, I'm really sorry that I won't be able to take the extra session because I had missed the deadline to fill the form. The mail just went into spam, and I really did not know that until I spoke with my friend. And yeah, so I'm really, really sorry about that. In case if you have any questions, please post it on the Google groups. Okay. So, okay, that should help. We can, Amber, I'm not sure. You have to ask the NPTEL people. Uh, at least when I gave the exam, I think around 10 to 15 days before the exam, I got, I guess. I'm not sure exactly. Okay, you have to take up with that NPTEL support. Okay, they will send it to you. You will get an email regarding that. Okay. I think even I was in a hurry when I didn't get my admit card before the NPTEL exam. Uh, they did quite some delay before as like it's usually they have a certain timeline and we are usually in a hurry. So they will send it to you according to their timeline. Okay. Yeah, yeah. I think even as far as I remember, it was something like that. I had the exam on April 28th. The same fuzzy sets, I guess. Fuzzy Set or another course that I was taking. I was giving two exams at the same time. So it was on two different days. One was on April 28th, one was on April 29th. So Fuzzy Set was there on one of the days. And I think I got it around April 17, 18, like that. So even I was in a bit of a hurry why I was not getting and all. So they'll send it to you. You don't have to worry. You just have to worry about your venue, uh, the location that you are going to get. Okay. Um, and I know Amber's background. Janani, what exactly are you studying? Like, are you in bachelor's or master's or PhD? Okay. So the reason that I'm asking is, uh, in my lab, we are going to hire a couple of people for internships and as well as for experienced folks as well. So I completely work on ultrasound and AI, but there are other electronics part side of it, firmwares and all of that as well, image analysis and all of that. So in case if anyone is interested in research internship, you can just apply through our my sorry my lab is Utsaha Lab from CPDM at IISc. So you can go through that website and you can just fill in the form and everything. Oh, okay, great, Jenny. Nice. Nice. Okay. So just wanted to let you guys know, because I did get a few emails regarding internship opportunities at IIC as well. So I'm just laying it out here so that if anyone else requires, so you can just let them know. So we mostly look at people from electronics as well as AI side. Okay, so that's the current hiring we have open in my lab. So in case if any one of you wants, you can always send an email to me. Okay. Uh, Simulation of communication systems using MATLAB. Oh, okay. Um, okay, maybe she's from a different department. I'm not aware. Sorry. Okay. Okay. So yeah, so that's it from my side for this course. And thanks a lot for both of you, Amber and Janani, for being in today's class. And uh, other special mentions also. There were a couple of people who were really, really active from before as well. So thanks a lot for everyone who were really active during throughout the course, and I wish you all the best in your career as well as your NPTEL exam if you're giving for this course. And yes, thank you so much, Jen. Thank you so much. Thank you, Amber. And Amber, special mention to you. You have been almost in every class, and the most active person I have ever seen, even including my previous courses. The consistency that you had, I probably didn't see in anybody, including myself. So yeah. So keep it up. All the best for you, Amber, and all the best to you, Janani, as well. As soon as you finished your PhD, do let me know. I'll also call you Dr. Janani from then. Okay. So yes. Okay. Thanks a lot for joining. So now I'll just end the session. Okay. Yeah. Bye, everyone. Thank you.